Hello, my name is Alicia and I will be presenting my project on bird species classification using deep learning models. In this project, I have fine-tuned two popular CNN networks, which are namely ResNet 50 and MobileNet V2, to classify images across the dataset. Our main objective here is to apply overfitting reduction techniques because since the dataset is very large and some of the classes have limited number of sample images, there is a high risk of overfitting. And finally, this entire model is deployed on Hugging Face application. For the data pipeline, I implemented a pre-processing strategy, which includes 7 advanced augmentation to improve the generalization. These 7 techniques are namely cropping, flipping, rotation, translation. We have visual techniques like color, jitter, and random erasing. And finally, normalization, ImageNet statistic. Furthermore, we also have optimized data loading. The batch size I have given of 32 and the shuffling has been enabled, which prevents the memorization. The pipeline further also maintains a clean separation between the training and testing, as well as the heavy augmentation is applied during the training to enhance the routeburnesss, while testing uses minimal processing for accurate evaluation. For ResNet 50, we use transfer learning starting with ImageNet weights, then modify the final fully connected layers for our 200 classes. And to prevent the general features, we froze the early layers and only fine-tuned the last few blocks. Furthermore, to also prevent overfitting, we apply data augmentation, including crops, flips, and rotation. And finally, added the dropout layers with a rate of zero point 0.5, used the learning rate scheduling, and we kept the batch normalization throughout. Finally, we trained the model for 30 epochs using cross entropy loss and Adam optimizer with a batch size of 32. Now, this is the result of ResNet 50. So as you can see from the matrices, the ResNet 50 achieved a top 1 accuracy of 53.74% with a top 5 accuracy of 80% approximate. And looking at the curves, the model's best validation accuracy was 53.7%, and which was reached by the final epochs of 29. However, the model actually finished training with a slightly higher validation accuracy, suggesting that some instability was there at the very end. The generalization gap, that is the difference between the training and the validation accuracy, was about 4.6%. So this indicates that the model did not severely overfit. However, over the 30 epochs of training, the model improved by 13% approximately in total. While the results are decent, especially the top five accuracy over 80%, we'll see a movement on how it is in comparison to our next transfer learning model, which is the MobileNet V2. So the MobileNet V2 architecture is also a pre-trained ImageNet. Uh, so here we froze the initial layers and we fine-tuned the inverted residual blocks. And furthermore, to prevent overfitting, we use the data augmentation techniques like random crops, horizontal and vertical flips, and brightness and contrast. We also introduced the pooling layer, which reduces the parameters before the classification. We added in a dropout of zero point 0.2 after the pooling layer. Furthermore, there is also batch normalization and label smoothing regulation, which is about 0.1%. And for the training, we did the training for around 40 epochs initially, but later when I noticed that the training accuracy was not increasing after 29 epochs, I later shifted it to 30 epochs, but initially we trained it on 40 epochs. And the batch size was 64. This was given larger due to the lightweight architectures of this model. So For the result of the MobileNet V2, the top one accuracy is 61.63%, and the top five accuracy was around 68%, which means that the correct classes were in the top five predictions over the 86% of the time. The per class accuracy was also strong, with at 60%, showing consistent performance across all the 200 species. Looking at the training curve, the model stated low but improved dramatically, gaining over 41% accuracy by the end of the training. Like the validation accuracy finally settled at around 61% in the final epoch, which was also recorded as the best accuracy overall. So, overall, the model showed a clear learning progress without a severe overfitting. The training accuracy finished at 87%, but the validation stayed close to 61%. So, however, this model clearly outperformed ResNet 50, which made it a clear choice for our classification task. So, MobileNet V2 outperformed ResNet 50 in every single matrix and not just accuracy. So, it achieved around 7.89% in the top one accuracy and about 5.23% higher in the top five accuracy, and did so while being seven times smaller, significantly faster to train and run. MobileNet V2 also showed better generalization with a validation accuracy of 61% compared to ResNet 50's 53.7%. Given these results, my recommendation is clear that MobileNet V2 is a superior model for the bird classification task, which offers higher performance and lower resource usage and better suitability for the real world deployment. Lastly, I deploy the model on Hugging Face, where the user can upload the image and select. Lastly, both the models were actually deployed on Hugging Face, irrespective of which performs better, so that there could be a clear classification. So the user can directly upload their image and select the model that they want to. Further, I also provided the users to choose the number of predictions they wish to see. So whenever the user uploads an image and when they click to analyze the image, they can at most see the top 10 predictions that the model give based on the confidence score. So this is one example. I uploaded the picture and it shows me the top five prediction rankings because I let my prediction display to be five. So that was it. Thank you.